So, it's 10 o'clock now. Welcome everyone. I am Yuriko Iwai from ispace. We'd like to start the progress report on Mission 1 of HAKUTO-R, the private lunar exploration program. Today's presentation is broadcast live from the front of the HAKUTO-R Mission Control Center in Chuoku, Tokyo. So let me share the agenda for today. Greetings from the organizer, then the mission progress report, followed by a dialogue between special guest astronaut Mori and Mr. Hakamada on Mission 1 planning and challenges. Then messages from HAKUTO-R corporate partners, discussion between special guest Mr. Kunio Kawara and Mr. Hakamada, and a closing remark. The first part of the session is scheduled to end at 11 a.m. So please have the press release ready at your hand. The second part will be available online from 11 to 11:15. If you have any problem with video or audio, please contact the organizer directly by email to pr@ispace-inc.com. So I would like to have Takeshi Hakamada, the founder and CEO of ispace. I am Hakamada, the CEO of ispace. Thank you very much for coming to the ispace event today. Here we are in 2022, and this year will be the ispace first launch year. This is the 12th year since we participated in Google Lunar X Prize race and decided to aim for the moon. In addition to the lunar exploration rover, we decided to develop lunar lander and go to the moon on our own. While there are various difficulties in manufacturing landers, it is progressing smoothly for the most part. We decided to host this event so that we can share the progress and plan and convey our thoughts on a mission at the beginning of the year when lander is launching toward the moon. I'd like to explain the current situation and our plan ahead so we can start the last spot for the success of the mission with all of the supporters. Thank you very much for today, for participating today. Thank you, Mr. Hakamada. Next is our CTO, Mr. Shimamura. Please tell us about mission progress. Good morning, I am Shimamura from ispace. First, let me share the latest status of our lander's assembly. Here you see footage of our flight model being assembled at AGG in Germany. So the lander's flight model development started July last year, and we are now in the final assembly stage. You can see various wiring and piping connecting the lander's components. After installing parts necessary to control the lander, the main fuel tank will be installed. The tanks are wrapped in a material called multi-layer insulation, or MLI. The rocket engine that powers our lander adopts a pressure feed engine utilizing helium as a pressurant. The helium is fed into two types of tanks through pipes, pushing fuel and oxidant out into the combustion chamber. The mixed and ignited fuel becomes a high-temperature, high-pressure combustion gas that is released from the thruster and propels the lander forward. So you can see our engineers at work. As you can see, our assembly integration and testing team performs the tasks on site. And as they need, they have to change some of the steps in order to make sure that we are able to carry out the mission successfully. So once the tanks is ready, we will be once the fuel tanks have been installed, the top and bottom monocoques of the lander will be assembled. After that, the radars, multi-layer insulation, solar panels, and the landing gear will be installed. Some of our customer payloads have already been mounted onto the top of assembly of the lander. And beginning in April, we plan to conduct final environmental test of the final model of the flight model, such as vibration and thermal vacuum testing at a dedicated facility in Germany. We are also currently preparing for Mission 2 in parallel with the development of lander for Mission 1. And ispace will bring our own rover on the moon to the moon for exploration in Mission 2. We are currently considering the details of the mission, but we started development of rovers at ispace Europe, subsidiary of ispace in Luxembourg. ispace EU has about 20 staffs, and since its establishment in 2017, it has been working as a sales base in Europe, but also has functioned as a rover development and analysis of the lunar data. In 2019, ispace EU signed an agreement with the ESR to propose the use of ispace lunar exploration mission at a pre-demonstration of ESA's lunar resource development. ispace EU has also been adopted by NASA for the commercial transaction program on the sales of regrowth on the moon. So Mission 2 will carry out not only the rovers but also payloads. We are making final adjustments to the payload currently being installed. And considering the development period of payload, Mission 2 will be launched in 2024. The launch rocket continues to adjust the launch timing on the Falcon 9 of SpaceX. This concludes the HAKUTO-R development progress report. Thank you, Mr. Shimomura.
Next, we will turn it over to Mr. Hakamada once again to outline Mission 1, which is scheduled to be launched this year. Mr. Hakamada, the floor is yours. ispace Hakamada is my name. I would like to talk about the Mission 1 plan once again. The purpose of Mission 1 is the technical demonstration on the space of the moon. Our goal is to demonstrate whether the lander can actually land on the moon. The lander is launched on the rocket, then it is disconnected and heads for the moon for about 3 to 4 months. The transfer orbit, which shows is fuel, or more accurately, propellant efficient, but takes longer to get to the moon, allowing us to maximize the amount of payload delivered to the lunar space and surface. After landing, the lander generates electricity from solar panels during the moon's solar day. It captures temperature information with a camera or sensors and transmits data to the Earth. During the lunar night period, that is during the period when the sun is not exposed, the mission will end because the power generation will not be possible. In Mission 1, we will transfer multiple payloads. The payload on board the lander will be provided with power and communication from the lander, and tests will be undertaken to demonstrate operation on the moon and to transmit video actually taken on the moon. The lander is currently being assembled at the Ariane Group facility in Germany, as Shimomura mentioned, and plans to conduct environmental tests using flight models beginning around spring. After the test, it will be transported to Florida, USA, where the launch is scheduled. At the same time, the Mission Control Center will control full-scale training in control operations to ensure lander control. The focus of the entire team is now focusing on the launch and the subsequent mission operations. As of today, the specific launch date is scheduled to be at the earliest, the end of 2022. Please pay attention to this year's developments. Now, I would like to welcome the special guest and introduce the points of the mission. The guest is Mr. Mamoru Mori, the first Japanese astronaut. Mr. Mori's profile will be introduced. In 1992, as a Japanese astronaut, came to the space shuttle, and as the engineer, 43 themes of the non-weight tests were conducted. In 2000, as the astronaut, the mission has been conducted. At this moment, he is the honorary director of the Japan lab through the technology. He is involved in various experiments. Mr. Mori, the floor is yours. The first point will be as automatic induction control and shock absorption at the time of landing on the moon. What does it mean? Mr. Hakamada, as you know, the gravity of the moon is about 1/6 of the Earth and is different from the global environment. So landing from orbit to the moon is about 6,000 kilometers per hour, and the moon has no atmosphere, so it is very important to slow down. It's a very high speed. Engine is used and propulsion is made in order to land on the moon. What is important is that the position itself of the lander is to be oriented to the exact location by utilizing thrusters to be accurately controlled and descending towards the landing site. The lander's guidance navigation control GNC system uses the latest sensors developed in collaboration with the Draper Laboratory, which has a track record of successful moon landings in the Apollo program while understanding the moon's environment. In addition, in order to minimize the impact during landing, we have adopted a technology that absorbs the impact on the landing gear itself. Inside the legs is a honeycomb-shaped mesh-like structure that breaks to absorb shock and protect the payload and other parts of the lander. I remember then, Armstrong, captain, when landing, saw with his own eyes, but on this occasion, it's different from those times. There is no person on the moon, and guidance navigation should be successful. That is right. And what kind of evolution occurred? As you say, in Apollo, the astronauts actually directly controlled. On this occasion, we have no people. It's no man control system. Therefore, the sensors and computer calculation capability is what we depended on. And the evolution of that from Apollo times have been significant. And the latest technology is applied so that safe landing was enabled. So the private, various competitions striving to go to the moon have not succeeded at all. On this occasion, ispace may be the first in the world to succeed. As you say, in the private sector, moon landing is not a success we have achieved yet. We will launch this year in the world. For the first time as a private entity, we are to land on the moon. I hope you'll be successful. Thank you very much. Next is the second point. There are 7 payloads to be transported to the moon, and there is a demonstration experiment. We at ispace have from the customers the payloads taken and mount them in landers and rovers and transports them to the surface of the moon or into the lunar orbits. That's the service we offer. In Mission 1, currently there's a plan to transport 7 payloads already to the Moon's surface and has already begun providing technical consultations on pre-transport payloads as part of the service. In HAKUTO-R, it aims to establish transportation technology through 2 R&D missions and to the commercial phase of transporting payloads of more than 100 kg per mission after Mission 3. It was about 10 kg for Mission 1 and 2, but Mission 3 will have 100 km per mission to be transporting the payloads, and we are developing that. It is expected that the production of multiple landers and rovers associated with high-frequency missions will improve technical reliability and improve the development efficiency. The initial mission is what it is, but 7 payloads exist, and multinational collaboration is involved there. Demands are multiple, isn't it? So recently there are a lot of demands. We mainly from Japan started, and we're a startup company, but it's not a demand just from Japan. There are other demands in other countries. JAXA in Japan had robots to be put, and NBRC and UA rovers maybe also sent, and other payloads, and from various countries there have been support given. In the future, from the globe to moon, transportation may be a new business that may occur. Is that so? Yes. Such business is securely being mobilized. The market is global then. That is right. The third point. Mission Control Center careful preparation. We have the lander's production finished, and it is handed over to the rocket side. And there is little physically about what we can do further. We cannot change further. After it's launched, we'll be focusing on the lander entering the space and how it operates. And once it's in space, it is this mission control center that operates the lander, whatever happens. We will repeat various scenario and simulations and rehearsals, assuming a number of situations in advance. This is very important for accuracy. On the other side, there will be the entire space missions to be seen, and people will be sent out. And in such missions, as a matter of fact, all of the information is within the Mission Control Center, and people will not go over this time. A very important role will be served by you. What about training? At this moment, Mission Control members are preparing for that. Various scenarios are assumed, and trainings have been initiated. We at NASA have various experiments accumulated, and it's a multinational initiative. But it's the first time for Japan, isn't it? That is so. Are you all right? There are a lot that we do not know yet. But for our side, we would like to cover most of the areas. Other than Japan, there are various countries where members who have experience in space will be involved in the mission control. Therefore, non-Japanese people are also existing, and communication is English, isn't it? So that is right. It is a global mission, and customers are throughout the world. Therefore, English is utilized in order to conduct the mission. So we are really a multinational team, and Japanese members are minor members. But we have a global perspective in order to conduct the mission. ESA or Europe Space Agency or Canada or NASA and JAXA also may be involved. Yes, JAXA from Japan also have members. I suppose you need a lot of experience. To start up instantaneously is difficult, but we look forward to that. Thank you very much. Then the last point, the fourth one, is the design unique to the private sector. Up to now, countries initiated the development. In Japan, JAXA had the mission risks to be secured so that it can be operated on properly. But we will commercialize more fastly. Basically, it's miniaturized and costs will be reduced and development speed will be accelerated. So Apollo technology has been more or less completed. Therefore, system integrator is our role, so that from outside, the existing parts will be assembled, so that secure development will be accelerated and weight will be reduced as much as possible. Launch costs and mission overall costs will be reduced. This can be challenged by the private sector too. Up to now, the country supported for development, and a lot of budget was necessary for that, and a lot of people have been involved. Therefore, mobility was difficult. But from the first time, on this occasion, payload will be utilized, and this payload from the control center may have some commands sent, or payload normally may be owned by some people and they will have commands from their own control center. What about this case? Payload will change, but basically in the mission control center, commands will be operated. MBRC will be the rover, so the developer will need to control, so they will be able to control remote mission control center. Connection will be enabled, so payload corporate secrets can be secured. Is that so? That is so. If so, this payload will be the next R2 mission connecting device, right? That is right. For mission 2 and 3, which will continue for the landing, and our continuous mission that will be continuing, will mean that it will be developing further more into the future. More or less everything being successful is rather difficult to conceive. On this occasion, R1, to what extent it will reach the success criteria has been determined, I suppose. That is so. We will land on the moon surface and take the customers to the moon and be a rover and partial payload. There may be detachments or communication may be offered too. That is our mission success criteria. A lot of challenges will be upcoming going forward, I suppose. That's right. Thank you very much, Mr. Mori Hakamada. HAKUTO-R Mission 1 point has been viewed, and Mr. Mori, due to your experience, is there some memory that comes in your mind, or is there some impression that remains in your mind? As Mr. Hakamada mentioned lastly about the mission success criteria, which is clear to me, we feel that there is always a malfunction occurring, so this may be 70 or 90%, in the end 120%, and if everything is successful it would be good, but it's rather difficult to achieve that level. It's very rare. In that sense, payload, from the customer's perspective, would be thought about. To what extent it can be enabled, and then about the moon's surface and payload will overtake from that point on. And there's a separation clearly, and in that sense, I thought it was good. Yes, we would take the customer's cargo and we should deliver them securely. That's our mission. Beyond that, why the customers want to deliver goods on the moon and the payload value to be communicated properly to the customers is our responsibility. You said demand is globalized, and ispace, which is similar to other companies in US, may be competitors to you. Sending to the moon as a payload may be rather expensive, and space, electricity supply, etc. Is it determined? Yes, we set the fee, and other companies' fee setting, price setting is more or less the same as ours. Up to now, the national development in space would be per kilo billions of yen or hundreds of millions of yen. That was the image. But we are a private entity, so cost will be reduced and it will become more convenient. So it will be half or much less than the amount from national initiatives. As the country, NASA, JAXA, and other countries' agencies will take the initiatives to send people to the moon, scale tagged, or there may be base on the moon too, and astronauts may be solicited too. It's not just sending people, goods to be sent beforehand, or collaborations will become very important. What do you think about that? That is, as you say, we also, in Moon Valley 2040 is a concept we have. In 2040, around 1,000 people will be going to the moon and be active there. If that happens, then do we deliver just human beings? Not so. In order to support the human activity, various goods on the moon are necessary. For that sake, infrastructure may be created, which is important. The more the people are sent, more goods are necessary. Therefore, transportation needs will be conceived as increasing going forward. Japanese people in the near future will have astronauts going to the moon for the first time. For that, supply may be conceived too. Yes, thank you for that comment. We would like to use the moon opportunity in that way. Presently, in JAXA, astronauts solicitation is about to start, and we would like to motivate the moon and also space initiatives. Japanese astronaut solicitation supporter is to be our role. Astronaut solicitation will actively be supported by ispace, and what we want to achieve, namely the Earth and Moon ecosystem creation, is what we would like to go towards together. ispace staff members seem to be very young and motivated as engineers. Will they become astronauts? Won't they apply for that? I've never asked each and every one of them, but there are some people who would like to be astronauts. Then they may apply for that role. Private entity activation and vitality is very important. Please work on that. Thank you very much, Mr. Mori, Mr. Hakamada. There are long discussions ongoing, but we would like to, at this point, close the session. Thank you very much, Mr. Mori. Thank you. Thank you very much, Mr. Hakamada.
Now let's move on to the next section. These are the companies participating in our HAKUTO-R Corporate Partner Program. There are various collaborations and business strategies being created. So today, we have messages from 8 HAKUTO-R corporate partners on their aspirations and the progress of their activities. First of all, this is the message from Tomohiro Nishihata of Japan Airlines.
I am Nishihata of Japan Airlines. This year is finally the year of the launch of HAKUTO-R. Japan Airlines first encountered the HAKUTO project in 2015. 7 years have passed since, and more than 10 years have passed since its establishment. We've been watching up close and working with them so that we have seen how difficult this challenge is. At HAKUTO-R, we are in charge of the welding piping and inspection of the parts of the lunar landers. And making use of our aviation maintenance technology, the day will come when JAL's technology will land on the moon with HAKUTO-R. I'm excited to be able to have my dream come true with you at ispace. For ispace, Mission 1 has been filled with more than a decade of thoughts. We recognize that this is an important project in Japan's space development. The last spurt for success in 2022, Japan Airlines will continue to support you more than ever before. Thank you very much, Mr. Nishihata.
So next, this is a message from Mr. Nojo, Mitsui Sumitomo Insurance Company Limited. I am Nojo of Mitsui Sumitomo Insurance. 2022 marks the year of launch of HAKUTO-R Mission 1. We have been supporting this great challenge since 2019 as a corporate partner in the HAKUTO-R program. We are developing moon insurance so that we can fully confront unprecedented risks such as journey of 380,000 kilometers to the moon and landings on the moon. We are fully involved in this project from the insurance field to realize a sustainable world utilizing lunar resources. The challenges of HAKUTO-R is also our own challenge. And we will continue to do our utmost to support it. Thank you, Mr. Nojo.
Next, this is a message of support from Mr. Kojima Company Limited from NGK and TK. Hello everyone, I'm Kojima of MKG Ceramics. The HAKUTO-R solid-state battery demonstration test on the moon is a big challenge for our company, which has been mainly engaged in the production of internal combustion engine parts for cars. It is a major challenge that has not been tried in the past, so it is a stepping stone to the space business for our company. Through these challenges, we will not only develop solid-state batteries, but also products that will contribute to solving environmental and energy problems both on Earth and in space. We would like to develop products that can contribute and realize a better future beyond your imagination. Thanks to ispace, thanks to everyone. We've been able to get this far thanks to you. Let's continue to work hard as a team, ignite your spirit. We wish HAKUTO-R is the success. Thank you very much, Mr. Kojima.
Now we have Mr. Yajima from Student Watch. I am Yajima of Citizen Watch. 5 years have passed since we have become a supporting company empathizing with the project of challenging uncharted territory of humanity, the moon and the universe. At the end of last year, we installed a GPS clock at this mission control center. As you can see, there is a time display above a main monitor of the mission control center. This compact receiver system receives time signals from GPS satellites and posts the accurate time on the display. I understand that a 1 second gap can lead to a critical incident in lunar missions, especially during orbit entry and lunar landings. Last summer, we delivered the lander leg parts made with a proprietary technology, super titanium. We are very proud to be able to contribute again with the time display in the Mission Control Center. We will continue to support HAKUTO-R for the launch of the Mission 1. Thank you very much, Mr. Yajima.
Next, a message of support from Mr. Ishii from Suzuki Company Limited. Thank you for your kind introduction. I am Ishii of Suzuki Company Limited. 2022 is finally the year of the launch of HAKUTO-R. The challenge of landing on the moon that we were able to achieve at HAKUTO together, the time for that revenge has come. Suzuki supports this challenge by analyzing the structure of the landing gear of the lunar lander. We plan to continue to conduct structural analysis of Mission 1 lunar lander to be conducted this year. And the next Mission 2 will upcome. But first of all, I wish the Mission 1 will be successful. I would like to support the project in the hope that lander will reach you safely until the landing in May. Thank you very much, Mr. Ishii.
We have received a message of support from Mr. Ishida, Sumitomo Corporation, and I will read on behalf of Mr. Ishida. So I am Ishida of Sumitomo Corporation. ispace HAKUTO-R program Mission 1 will finally come true this year. It embodies the enterprising spirit of ispace, landing on the moon, a great achievement no private company has ever realized before. It is highly aspirational and encouraging for our own space business. Through Hamilton Sandstrand Space System International, our joint venture with Collins Aerospace, we have contributed to the development of space field by working on life support equipment such as a spacesuit for the International Space Station. In the space sector, development driver is shifting from government space agencies to private companies. While supporting the HAKUTO-R program, which aims to provide private transportation services to the moon, we hope to discover new species of space business and expand our business in space sector, capitalizing on our expertise as trading company that has engaged in various businesses. As the importance of the moon in space development grows larger, we would like to contribute to the development of the space sector. And your activity leadership has been very encouraging. I hope 2022 will be a great year for all of us. Thank you, Mr. Ishida.
Next, there is a message of support from Mr. Nakamura of Takasago Thermal Science Company Limited. I'm Nakamura of Takasago Thermal Science Company Limited. In December 2019, we became a corporate partner of the HAKUTO-R program and began collaborating with ispace. We are developing a water electrolytic device for the Moon with the ispace people for HAKUTO-R mission 2. Currently, we are designing the test models and conducting environmental tests, aiming to be the world's smallest and lightest water electrolyte device with durability based on the use of the Moon. We are making progress step by step towards the success of the world's first project called hydrogen and oxygen generation on the Moon. The dreamlike HAKUTO-R program is finalized scheduled for Mission 1 this year. I think it's been a long way to go for the first private landing on the Moon. But if you're at ispace, keep your body in mind so that you can do your best. We wish the mission success. Thank you very much, Mr. Nakamura.
I really would like to appreciate all of the support from HAKUTO-R corporate partners.
Next, I would like to present the original drawings of lander, which has been specially written in conjunction with this announcement. Mr. Hakamada, the floor is yours. I am Hakamada from ispace. As the message has been received, HAKUTO-R partner companies who are engaged in activities to create lunar industries by enlivening HAKUTO-R through the dissemination of information to the world, along with their contribution to actual missions. Thank you very much. As part of this activity, an illustration of HAKUTO-R lander drawn by mechanic designer and Gundam designer Kunio Ogawara will be released as an advertisement for the Asahi Shimbun tomorrow in coincidence with the press conference. I saw it earlier and it is really cool. I feel that these activities will lead to more people becoming interested in HAKUTO-R, and the design is very important for that. I hope more people will aim for the Moon together, having interest in HAKUTO-R. On this occasion, we are visiting Mr. Okara. We have a visit from him. He has been specially designing for this initiative. We will introduce the profile of Mr. Okara. Mr. Okara is Japan's first professional mechanic designer in animation works and has worked on a number of works, including mobile suits that appear in Mobile Suit Gundam series. I would like to hear the introduction and story of the original picture immediately. Mr. Okara, the floor is yours. Thank you very much for the introduction. Thank you. Then, I would like Mr. Okara to introduce the original picture. This illustration is where Gundam theatrical I-Sensi is where the visual was taken up by myself for the first time. Up till now, several hundreds of illustrations have been drawn. 99% of them is what I designed by myself. So as on this occasion, an important project where visual is drawn by myself is a pressure to me, and there were a lot of difficulties. Technically speaking, and it is the B2 version in poster color, and for the configuration it had been already determined. The Earth and the space and the Moon has been drawn. Lander is lastly drawn. Space means that a lot of stars symbolize it. The Moon and the Earth, and also the stars as a background may be placed. On the brush, white or light blue is penetrated, and then I slap it on the canvas, and it becomes a star in space. There are a lot of texts included here on this occasion. Therefore, the space or stars, if too expressed, then the text will disappear. So, with that instruction, the stars were minimized. For that sake, space was written, drawn once more, and the stars were deleted. My wife came to clean the office, and she was mopping the floor. And for some reason, the space color, because airbrush is scattering paint, was on the floor. And when drawing, from the thruster, there were some dispersions. And the light to be expressed was a method I thought about. I used pastel. With that pastel, reflection of propulsion was expressed. A lot of pressure was on me at that time. At the same time, there were other assignments, but I prioritized this project. Thank you very much. It's a very cool drawing. The space, as you mentioned, had the stars properly expressed. At the same time, propulsion, reflection, lights were very cool to see. I myself love this kind of drawing. I came in the space world because I had a strong image of this. I myself, when I was a child, viewed Star Wars. Star Wars is the basics of the Gundam mecha drawing, so there may be some copying done. I myself love Star Wars. People of my generation is in the Gundam generation. I feel that I learned the characteristics of living in space, of colonies, of lunar cities through the early Gundam series is what I liked very much. Colony, people living in space means they're consistent with the Earth, and it resonated with me. And the first step for that is within this project. And Gundam comes after that. Space colony was about to be made in the location where you will have children and have them brought up. Destruction of the Earth environment throughout the world is a common recognition held. More than 40 years have passed since Gundam was first introduced, and it's still supported nowadays. In this way, I myself like Star Wars, Gundam, and other SF stories. What people create is coming more and more similar to that. In 1972, there was Kagaku Ninja Tai Gatchaman, a production, and I was involved in designing that. And watches having monitors at that time was unimaginable. It's an animation, therefore they could be designed in that way. But in just half a century, people have smartphones, which is similar to having a computer. I was very worried, but the monitor was designed at that time. In the next 2 or 3 decades, I feel myself that Gundam's envisioned world will be materialized, and we would like to be involved in that too. Early on, you mentioned something that I would like to ask Mr. Okara. There are robots in the space, and Japanese private entities developed robots landing on the moon. And what do you think about that? Well, in my generation, coming to the moon's surface was seen on a real-time basis for robots. But if you work in animation, nothing scientific is considered. It's just a thorough entertainment activity. So such an era may be late to come or maybe quite early to come. So I don't know about the speed. But in various fields, realizing one's dream is what really impressed me in that sense. Thank you very much. In the past, or rather 10, 20 years ago, there was an image you had, and that is about to be realized, and that is a major cycle. So you first of all created that world and still continue to be involved. It's very irresponsible, though. If it's designed based on scientifics, then it doesn't reach the children's hearts directly. Therefore, entertainment is fully embedded here. In the Gundam car, it's not interesting to see normal cars running. So something specific is necessary. Yatama or other series also was handled by myself. Character creation of that is more direct. So the lander itself to be designed is my wish. But I don't know whether I'll be alive at that time. Thank you very much. A very interesting topic has continued. Mr. Okara, lastly, please give us a message for support for HAKUTO-R. I am quite elderly now. The present children will become more interested, and the Gundam world will be viewed, and destruction of the Earth environment should be constrained, and people may go to the space. From young ages, I hope people will be interested in this spatial world. Thank you very much. The time has come, therefore, Mr. Okara, Mr. Hakamada, thank you very much. Thank you.
Okay, well, it's almost to the end of the session, so I'd like to have a closing remark from Hakamada-san. Well, it's finally the year of launch. We have received the cooperation of various people to make this first mission a success. As for the corporate partner, Japan Airlines, Mitsui Sumitomo Insurance, Nippon Special Ceramics, Citizen Watch, Suzuki, Sumitomo Corporation, Takasago Thermal Industry, Sumitomo Mitsui Banking Corporation, and SMBC Nikko Securities. And besides them, Hilltop and Fujikin have decided to participate as supporting companies. So in addition to these companies, we are supported by space development, lunar landing professionals, and parts manufacturers and various manufacturers in Japan and overseas. Of course, there are also supporters club who have always supported our activities since our time of HAKUTO. We will launch lander toward the moon with all your spirits on it. The first month of the year of the launch is here. Looking back on the journey so far, I think about people who have rendered their hands and supported us. And I also think about the colleagues who have walked along with me over many obstacles. We are able to come this far because of the power of everyone who participated in this program. We will continue to strengthen that power and move forward. And we will realize continuous moon development. Please look forward to this year's HAKUTO-R Mission 1. Thank you for your continued support, and thank you so very much for participating in today's event. Mr. Hakamada, thank you very much. We have a few minutes left before the end of the session, so let's try to answer some of the questions on Slido. Okay, the first question, I should read it out. So the flight model assembly is being done in Germany, and I understand the moon surface analysis is being done in Europe. Why is that? Thank you for the question. I would like to have CTO Shimamura-san answer that question. The flight model is being created in Europe, and of course the analysis is being done in Luxembourg. We do have our office in Europe and US, so we are quite involved globally. So it's not that we are trying to work in a special area or special physical area, just depending on who we are working with at the time, where the partner is available, and so on. So the lander assembly is being done in Germany because we are working with Ariane. They have a propulsion system, and they are supplying the very heart of our lander. That's why we decided to assemble the landers there. And Luxembourg is working on the data analysis. And because we do have very strong experts, and that's where we started the analysis effort. And of course, data analysis is going to be a core of our mission going forward. And so while we are starting in Europe, we will expand to Japan and other areas as well. And let me add something. The Luxembourg, the government is strongly involved with space resource development, and data analysis is crucial for the space resource development. That is why we are working in Luxembourg right now. Thank you so much. Okay, the next question is about the lander. The final design was shared in July last year. I know you've done some actual work that's been done since then. There may be some details that's been changed. So if you have any changes to the original design, please share that with us. Okay, well, let me try to answer that. The initial design, it hasn't actually changed much. So basic functions and the parts and the forms of the parts have not changed. But internally, some of the main improvements have been made on the components. And there are various conditions about temperature and vibration. So we have, of course, adapted the necessary changes. But externally, and there isn't really a major change. So it's a series of minor changes just to make sure that it works properly. Okay, thank you so much. Next question is going to be the very last one because of the time constraint. So the mission 2 has been moved from 2023 to 2024. Why is that? So if you can actually make a comment. Yes, well, as Shimamura-san explained earlier, there are internal and external factors, and so we decided to change the timing of the launch. The mission 2, engineering development schedule, and some of the customers' voice, we have reflected some of the opinions from our customers, and that's as a result we decided to postpone it to 2024. Thank you. Okay, so this is the end of the first session. Thank you very much for your participation.
それでは続いて、第2部としてミッションコントロールセンターの内部で今後行う予定の
Mission Control Center.
そこを一緒にご覧いただければ
What is happening internally will be introduced. Continuing from the first part, we will have to have Mr. Mori also attending. I'm really excited. I've seen it several times and I'm always nervous when it occurs. Thank you. What do you think about the room? The screen is very enlarged. In Apollo times, it was embedded, but there is something very big now. Various positioning changes have occurred. We will start the training, and what we train about will be briefly by using the whiteboard be explained from the staff. As you go into space, there are 2 sessions. First, from Earth to Moon. Low energy trans-orbit is what it is. It's energyless. There's no load there. After that, you go near the moon, and the third is you land on the moon, where you change your posture. Those are the fourth. The final part to be explained today. You land on the moon, and it's very difficult to do so. Within other missions, there aren't many success stories. Most have failed. So this will be trained, and you will view that. More detailed, Alejandro will explain this.
So today we're going to rehearse the last part of the mission, which will be the approaching and the braking burn, and then we will perform the descent. This is short so that we can see it on the TV today.
Yep. ちょっと簡単に日本語でさっき申し上げた通り最後の
Briefly in Japanese, you change your posture and land on the moon. And today, here, the simulation will be shown. And we would like to show this. Maneuver 3, from which landing is how long?
From maneuver 3 to final landing.
In reality, it takes around 100 minutes, more than 100 minutes.
100秒ですね。約100秒です。
So we will make
100 seconds,
short.
approximately.
Today we will have a short.
Very short.
今日は訓練で短くします
Today,
けれど
we
も。
will
はい
shorten it due to the training purposes.
それではじゃあ
So we can
Then-
talk about the displays.
Okay, please.
So we have 3 displays. The first one is where we have some telemetry.
左が3つスクリーン、大きなスクリーンあるんですけど、左がテレメトリー、宇宙船の状
Left
況
hand
を
side is telemetry,
On the
the
second one, we have
spaceship
the orbit
situation.
and the position of the lander in real time.
2番目が
The
ランダーの
second
ピッ
is
チと、それ
lander
から
positioning
状況をあそこに
and the
リアルタイムで
status,
示している。
real time
Hi.
shown.
And on the last one, we will have the planning activity. So today we have the schedule of the activities of the day.
一番右が今
On
日
the
の
far
ス
right
ケジュー
is
ル。
today's schedule.
運用当
On
日
the
のこの日
day
のスケジュール
of
が
the
飛んでるわけですけ
operation,
ど
the
も、そういう
schedule
ふうに
is
スケジュー
shown.
ルを表示しているという状況で。
The stage is
And then
shown.
we have 3 clocks. First one is where we have the timing until the next ground station.
上に3つ
At the
時計
top
があるんですけど、
there are
それぞれ
three
違った情報を示してます。左側
They
が
show different
地上との交
information.
信を
Left
するため
hand
のグラ
side
ンド
is
ステーション。
communication,
そこといつ交信
a
ができるか
ground
という情報を載せてます。
station
宇宙から地球
communication
に
when
デー
it
タを
can be
送って
done.
通信をするため
From
に
space
非常に重
to
要です
the
の
Earth,
で、
there is
その情報が
communication sent, and
On
it's
the
very
second one, we
important.
have the UTC time, the Japanese time, and the status of the GPS
Okay.
servers.
Okay.
In the center is the time, Japan time, and MCC UTC time. GPS information is shown. The time is accurate at all times, and it can be confirmed.
And the last one is a customizable place where we can put time to some activities, and in this case we have time until the birthday of Andresan.
What is it?
Just to show something.
On the right-hand side has flexibility on the screen. Various information can be put. Today, Andre's birthday. Until then, how much longer is shown here. Some kind of play aspect is included. It says citizen in the center. Does it mean the clock is provided from citizen? This GPS system is supplied from citizen, and accurate time is monitored at all times.
So let's go.
Then let's try to the mission training. Mr. Mori, would you like to have a headset? I think you can hear the real communication. Actual training will start. During the training, operation will be flowing. We will not be involved. We will dialogue at the background.
Yeah, sure.
We heard.
Okay, so everybody, please stand up. We'll be ready for the simulation. We have a critical mission today, small LOS during our activities, so be ready for any contingency. So please be sharp and concise on console. Ad Astra, go ahead.
We'll start now.
Okay, team, we'll start by doing a voice check on my loop. FD.
Go.
Guider.
Go.
GC.
Never go.
Spacon.
Go.
Avio.
Go.
We're checking the sound.
Okay, everybody, the sim will start on my mark. 3, 2, 1, mark.
Okay, team, we're approaching the breaking burn. Please prepare your displays and your tools, ready for all scenarios. GC, on my loop. Please coordinate with ESOP regarding the AOS.
Copy that. ESOP, GC on ESOP loop.
Go ahead.
Is New Norcia ready for transmission?
New Norcia is ready for transmission. We are following the lander.
Copy. Thank you very much, sir. Flight, this is GC on your loop for ESOP connection.
Go ahead.
ESOP is ready to transmit as soon as we have the lander in range.
Copy that. Okay, team, AOS is in 10 seconds. Be ready to start
We're
processing your
studying
telemetry.
until now. We're confirming.
Flight, this is Alex on your loop for an anomaly.
Go ahead.
It looks like we are not generating enough power. Our battery
Some
is
abnormality has
supposed to
been
be
found.
Okay, copy that. Team, this anomaly is what we've been trained for. Ops, do we need to act urgently or is the lander safe?
negative. The lander is currently safe.
Copy. FD, how much time do we have until the burn?
We have 5 minutes.
We will be entering LOS in a few seconds.
Okay, team, be ready to propose your ideas during the LOS.
Problem has been detected, and we're confirming on the status.
3 possible things that could be wrong. Number 1, we may have the wrong attitude. Number 2, our batteries may be seeing too high of a temperature. Or number 3, one of our solar panels may have been damaged.
Okay. Team, on my loop. Guido, what do we do in case of the wrong attitude?
今メンバーからコードが間違っている可能性、バッテリーの高温
The
状態の可
member
能性、それ
is
から
saying code or battery or solar panel may have some issues. How it can be countermeasured?
Okay, no. What do we do in case the panel is damaged?
We can change our attitude to let the sunlight hit the other panel.
Yeah, that's a fantastic idea, Rox. Okay, Guido, could you please prepare a second vector to support that anomaly? Okay, team, so it seems like we have a plan. So in terms of the wrong attitude, we execute procedure 34. In terms of the high temperature, then we execute the emergency procedure 106. In terms of the damaged panel, then we load the new attitude vector and we execute procedure 34. We have about 1 minute to identify and solve the issue before it's too late before the maneuver.
それぞれの問題に対して事前に準備されたプロシージャーがあって、それを走らせることで
problem, there are procedures in order to take the countermeasures.
We
are pre-configured.
Copy that.
And flight we have AOS now.
Attitude is nominal flight.
Flight, it must be a damaged panel.
Okay, speak on. You are go to launch procedure 34.
The problem may be some kind of failure to the solar panel.
Procedure executed.
Flight, this is ops on your loop. It looks like the battery is now starting to charge nominally.
Okay, that's great
今
news.
回で使える太陽光パネルを
Usable solar panel has been replaced in order to secure the energy.
Okay, copy Guido. I need a go, no go from the team for the braking burn. FD.
Go.
Guido.
Go.
GC.
Go.
Spacon.
Go.
Avio.
Go.
Specialist.
Go.
Ops.
Go.
Okay, copy all. We'll go for break and burn, about 1 kilometer from the surface.
1キロのところでブレーキングバーンするために今全員 GO のサインが出ましたね。
Kilo, there's an all-out go in order to break together.
Flight, this is ops. Breaking burn has been confirmed.
Okay, copy that. Guido, team, can I get good thumbs? Okay, we're about 20 meters from surface.
20メーター。
15.
It's 20 meters, 15 meters. We become more nervous and tense.
In the terminal. And we have touchdown.
今着陸しました。
We've touched down.
素晴らし
Wonderful.
い。良かったですね。
It's good.
Report the telemetry.
All systems are nominal. Everything looks healthy.
Okay, team, good landing.
Okay, everybody, simulation is over. Thank you very much for your support. You have done a very good job.
森さん、なんか一言。
Mori-san, do you have a word?
Well, this reminds me of my days when I was involved in my mission, and I was very much excited and remembering this. And thank you very much for showing us your simulation. And the important point here is teamwork. One team.
Thank you very
Good
much.
luck.
Thank you very much for your precious comment. チームワーク大事ですから。
Teamwork is important, so let's work hard on it. And what we showed you now made him remind his past experience. It's a very encouraging word. So that's the level of work we need to continue in order to go to the moon. Thank you very much for the comments and thank you for today. With that, Mission Control Center training scenario will be concluded. Lastly, please look back here. This way, Mission Control Center has various training conducted. We showed you just one pattern only today. Members get together in order to go to the moon, so we hope you will support us. With this online real-time release has been ended. Thank you very much. With that, the second section of this event has been concluded. Thank you very much, Mr. Mori. Thank you. Please do your best. Yes, we will.